Let's say your friend came to you with this problem they were struggling with after their class. They were given this equation, x to the 6 plus y to the 4 equals 36, and being asked to find its first derivative. At first they tried to use the power rule since it was x to the 6, but this y to the 4 was really messing with them. So instead of isolating for y, which can sometimes be borderline impossible, too impossible, they can use the method of implicit differentiation in order to find dy by dx. It is actually a pretty simple method. There's only a few steps, so let's get right into it. So we're going to want to actually take the derivative with respect to the independent variable. In most cases, that is going to be x, especially for equations like this where there's like a y and an x, but it's always important to make sure. But I'd say 95% of the time, for the problems you're given, you can probably just assume it's x. So we're going to take the derivative of x to the 6 plus y to the 4. And we also have to take the derivative of both sides of the equal sign. So we can factor this in using the summation rule. So that just means we can take the derivative of each term separately. So we're going to take the derivative of x plus 6 first. This is just a simple power rule problem, or power rule derivative. So I'm going to bring that 6 down, x to the 5 plus. Now this is our dependent variable, and because of that, we're still going to need to differentiate with respect to x, and we're going to actually be using the chain rule. So using the chain rule, we're going to take the derivative of the first term, which is just the power rule again, and we're actually going to multiply this by dy by dx. Usually you would take this derivative in the chain rule, but we don't actually know what that is. So that is the term we're looking for. So I'm actually going to write it as y prime, but you can also write it by dy dx, whatever works. And then the derivative of 36, a constant, is always 0. So now we're going to want to isolate for y prime. So I'm just going to do this step by step, just for the first one at least. So I'll move over that 6x to the 5 to the other side. And then I'm going to divide 4y to the 3 by both sides. 6 divided by 4 is 3 over 2. So I'm just going to simplify it right away. And then that is x to the 5. Ooh, sorry about that. X to the 5, make that a little better, divided by y to the 3. And that's the solution. Pretty simple, only took a couple minutes. And you're able to find the slope at any point of this curve now using that. So pretty neat. Okay, let's go into a slightly more complicated example. Okay, so for this curve, you'll see it's a slightly more complicated example, but it is really just the exact same process as before. So we're just going to want to take the first order derivative of, again, the independent variable. So it's very important you actually understand what you're deriving or differentiating for of both sides. So the very first thing, again, using the difference rule, so we're just going to take the derivative of each separately. This is actually the product rule. We have two variables that we're going to need to differentiate in this equation. So we're going to take the derivative of the first term and leave the second on its own. So the derivative of x is just 1. So this term becomes y. We're going to do the plus, and then we're going to leave the x alone and then take the derivative of the y, which is just y prime, minus, and then this is just 1 because the derivative of x is 1, then equals, and then the derivative of this is just y prime. And again, y prime just equals dy over dx. So we're trying to isolate this. So looking at this, we will want to get all of the y primes on the same side. So I'm just going to write xy prime. Bringing this over to this side, I'm just going to minus that y prime equals. I'm going to bring this y over to the other side. So moving it there, and then add this 1 as well. So tried explaining it. I'm not going to write out all the steps, but I just wanted to put all the y primes on one side. And then if we factor that out. We get this. And then our final equation, just because I'm running out of a little bit out of room, is just this x minus 1 divided by the negative y plus 1. Let me write that down, which is our final answer for this. So again, basically the same process. We just had two y primes, so you just have to isolate it both on one side. Okay, let's go over a slightly more difficult example. So this graph, e to the y minus x plus sine to the x plus y equals 0, is actually represented by this graph up here. It has a bunch of these lines, and we're asked to find the derivative. Now, it is the same process as before, so you'll see that the y isn't raised to anything, but we actually have this y inside of these equations, so we will need implicit differentiation in order to do this. And again, it's the exact same as before. So instead of rewriting this 1,000 times, I'm actually just going to rewrite it here. And then the derivative of 0 will be 0, so I won't write it over here. So we're going to need to take the derivative of both of these equations. So we're going to need to use the chain rule. So bringing this out, okay, so everything's been written out. So we'll take the derivative of the inside function just like we would in the chain rule. So the d by dx of y is just y prime, which again is dy over dx. This is what we're trying to isolate for. Minus 1, because the derivative of x is just itself. Or sorry, not just itself. The derivative of x is just 1. Times. So because of the chain rule, remember we differentiate, we take the u outside and then differentiate this. So e to the u is just e. And then I'm going to put back that u, which was just our variable, so y minus x. And if you're confused on why I wrote it this way, I was just going by the chain rule definition. Next, we're going to add, so again, we're going to differentiate this again. So I'm just going to do these because this is all going to be multiplied by itself. The first derivative of x, or sorry, the derivative of x is 1 plus the derivative of x with respect to y, or sorry, the derivative of y with respect to x is y prime. Very important to get that right. And then the derivative of sine is just cos. And I'm going to put back in the x plus y. And again, this all equals 0. So I will speed up again. Okay, so I just simplified everything. I should have wrote some brackets here. I just simplified everything, or sorry, I expanded everything. So we have all of the terms expanded. And now we are going to want to isolate for those y primes. Okay, now that we've got our y primes all on one side, we are going to take those out and then divide this by these terms, same as we did before. So I'll do that real quick. Okay, and there we have it. I know I sped through this section quite a lot. It was just basically rewriting the same thing over and over. So hope that it still made sense. Basically, the exact same thing as we were doing this entire time, which was isolating for y prime. And then yeah. Hope that this video helped. Subscribe if it did, and leave a like and comment if you'd like to see anything else or add any questions. Thanks.